BGV theorem confirms beginning of universe. The BGV theorem points to a beginning of the universe, and a beginning of the universe points to a supernatural cause, God, that is transcendent to the universe. The Borde-Guth-Vilenkin BGV theorem is one of the most significant developments in modern cosmology, offering strong evidence that the universe had a beginning. Developed by physicists Arvind Borde, Alan Guth, and Alexander Vilenkin in 2003, this theorem addresses a wide range of cosmological models and demonstrates that any universe which has been, on average, expanding throughout its history cannot be eternal in the past. It must have a boundary in time. This conclusion has profound implications for our understanding of the universe, challenging the notion of an eternal cosmos and pointing to a beginning. This video explores the BGV theorem, its implications, and how it strengthens the case for a finite beginning to the universe. Understanding the BGV theorem. The BGV theorem arose from efforts to understand the nature of the universe within the context of general relativity and inflationary cosmology. Alan Guth, one of the co-authors of the theorem, is widely known for developing the theory of cosmic inflation, a rapid expansion of the universe that occurred fractions of a second after the Big Bang. While inflationary theory resolved many problems in cosmology, such as the horizon and flatness problems, it also raised questions about the possibility of an eternal universe, particularly in models suggesting eternal inflation. The BGV theorem addresses these questions by focusing on a key aspect of any cosmological model: the average rate of expansion. According to the theorem, if the universe, or any universe within a multiverse, has been expanding at an average rate greater than 0, then it must have a past boundary in time. In other words, such a universe cannot have existed forever. It must have had a beginning. Key points of the BGV theorem. 1. Applicability to a broad range of cosmological models. One of the strengths of the BGV theorem is its broad applicability. Unlike some other cosmological arguments that are specific to certain models, the BGV theorem applies to a wide range of cosmologies, including inflationary models, cyclic models, and even certain models of quantum gravity. Implications for inflationary cosmology. Inflationary theory posits that the universe underwent a period of rapid expansion shortly after the Big Bang, smoothing out irregularities and explaining the uniformity of the cosmic microwave background radiation. While some versions of inflationary theory suggest that inflation could be eternal into the future, the BGV theorem shows that even these models cannot be eternal into the past. Regardless of the specific details of the model, if the universe has been expanding, it must have a beginning. 2. A boundary in time. The core conclusion of the BGV theorem is that any universe with an average positive expansion rate must have a boundary in time. This boundary marks the beginning of the universe and suggests that time itself may have started at this point. The concept of a past boundary, the idea of a past boundary in time, challenges the notion of an infinitely old universe. Before this boundary, there is no meaningful concept of time, space, or matter. This aligns with the traditional view of the Big Bang as the origin of the universe, where time and space came into existence. The BGV theorem supports this view by showing that any expanding universe, regardless of its specific properties, must have a finite past. 3. Challenges to eternal models. The BGV theorem poses a significant challenge to models that attempt to avoid a beginning to the universe. Some cosmological theories, such as certain cyclic models or proposals involving quantum fluctuations, suggest that the universe could be eternal and undergo infinite cycles of expansion and contraction. However, the BGV theorem demonstrates that even these models must have a beginning if they involve periods of average expansion. Implications for the multiverse hypothesis. The multiverse hypothesis, which posits the existence of multiple or even infinite universes, is often invoked to explain fine-tuning and other cosmic phenomena. However, the BGV theorem applies to each individual universe within a multiverse, provided that the universes have been expanding on average. This means that even within a multiverse, the individual universes, or the multiverse itself, cannot be eternal in the past. This presents a challenge to those who argue that the multiverse could eliminate the need for a cosmic beginning. The philosophical and theological implications. The conclusion that the universe had a beginning has profound philosophical and theological implications. The idea of a beginning points to the need for an explanation of what caused the universe to come into existence. This is evidence for a transcendent cause or creator, something beyond the physical universe that brought it into being. 1. The principle of sufficient reason. The principle of sufficient reason indicates that everything, or state of affairs, that begins to exist must have an explanation or cause that transcends itself. If the universe began to exist, it follows that there must be a sufficient reason or cause for its existence. The BGV theorem strengthens this line of reasoning by reinforcing the idea that the universe is not eternal, and thus requires a cause that transcends time, space, and matter. 2. Aligning with theistic cosmology. The BGV theorem aligns well with theistic cosmology, which holds that the universe was created by a transcendent being. The concept of a beginning to the universe, as indicated by the BGV theorem, is consistent with the idea of supernatural creation, where the universe is brought into existence by a supernatural cause outside of itself. That supernatural cause is God. 3. The limits of scientific explanation. The BGV theorem also highlights the limits of scientific explanation when it comes to the ultimate origin of the universe. While science can describe the processes that occurred after the beginning, such as cosmic inflation and the formation of galaxies, it reaches a boundary when trying to explain what caused the universe to begin. This boundary shows that the question of why the universe exists lies beyond the scope of scientific inquiry and is instead a philosophical or theological question. Conclusion: the Borde-Guth-Vilenkin BGV theorem is a powerful tool in cosmology that points decisively to a beginning of the universe. By demonstrating that any universe with a history of expansion must have a finite past, the theorem challenges the idea of an eternal universe and reinforces the concept of a cosmic beginning. The implications of the BGV theorem extend beyond cosmology, touching on profound philosophical and theological questions about the nature of existence and the need for a cause or reason for the universe's origin. While the search for a complete understanding of the universe continues, the BGV theorem remains a cornerstone in the argument that the universe had a definite beginning in time. So, the BGV theorem confirms the beginning of the universe, and the beginning of the universe points to a supernatural cause, God, that is transcendent to the universe, as we have discussed in other videos. Thanks for watching. Please like, share, and subscribe, and comment below if you agree or would like to add your thoughts.